Okay, we're gonna do the greater than lesson again this week. Now, one thing, I'm gonna tear up a piece of paper. Remember, if it eats X, that means the range, your solutions go this way. If it eats the number, that means it goes this way. Okay, so assignment 7, week 7. Okay, number 1, we got to solve these inequalities and graph the solution set. So we got x minus 6 greater than negative 2. So I make my number line. So this is my sign here, the greater than, and I make my wall there, 1 dot circle. And that number is a positive number, so that means the sign is going to stay the same. The number in the circle, the multiplying number with the x. Okay, plus negative. So before we divide by 1, we got to get rid of the negative 6. So we plus 6. So line your sign up. You got 1 dot x over here, and over here you got negative 2 plus 6. Negative 2 plus 6 is 4. And then I can divide by my 1. Okay. Now I come over here. After I divide or multiply, I come over here. The x is before the sign, and then 4 divided by 1 is 4. So that's what I graph. 4 is a critical number. Circle. We're not going to fill it in because we don't have the bar under the greater than sign. And then when it eats the x, it goes this way. So x can be any number going that way. Okay, problem number 2. 16 less than or equal to negative 2x. So make your wall, dot circle. Okay, this time the multiplying number of the x is a negative, so the sign, that sign needs to be flipped the other way. Now I can go straight to divide because I don't have anything outside that I have to add or subtract, so I'm going to divide by negative 2 and divide by negative 2. And now I can come over here because now the x is all by itself, but it's after the symbol, so we need to put it after the symbol. And 16 divided by negative 2 is negative 8. Okay, so negative 8 is a critical number. Now it eats the number, so when it eats a number it goes this way, so x can be any number that way, like negative 9, negative 10, negative 11, anything that way. Okay, number 3, x divided by 3. This one's kind of a little bit different, okay? Now we're going to make our wall. And I'm not going to put a multiplier on the x because x is being divided. There's a line under the x, so I'm not going to be putting a 1 there. Okay. So when I circle it, I circle the divider with it. Now you treat the divider the same way as you did with a multiplier. The divider is positive, so that symbol is going to stay the same. And I don't have to add or subtract, but I need to do the opposite of divide, which is to multiply. Now x comes before the symbol, so we put it there, and then 3 times negative 10 is negative 30. So that's how you handle dividers. You treat them like multipliers. Wall, circle, you just don't make the dot. Okay, it eats the x, so it's going this way, so x can be any number going this way. Okay, number 4. We have 6 parentheses x minus 1 less than negative 18. Okay, I need to get rid of the parentheses, so I need to apply the distributive property. Okay, so I do my rainbows, so I got 6 times 1x and 6 times negative 1. Okay, so 6 times 1x is 6x, and then 6 times negative 1 is negative 6. And then I get to my symbol, and then negative 18. Now I can do the wall because I see the only x has a multiplier of 6. It's positive 6, so that symbol is going to stay the same. Okay, now before we divide by the 6, we got this negative 6 we have to get rid of. It's negative, so we're going to add it. And then 6 dot x, negative 18 plus 6 is negative 12. And now we can go ahead and divide. So now when I'm dividing or multiplying, I come over here. X comes before the symbol. And then negative 12 divided by 6 comes after, and that's negative 2. So that is, I now know what to graph. So negative 2. We would not fill in the circle because there's no line, and it eats the number, so it's going to go this way. Okay, number 5. 5x plus 6 is less than or equal to 8x minus 18. Now I can't make the wall because there's two x's, okay? So let's mark out the smaller one and either add or subtract that. So it's positive, so we're going to minus 5x. And then minus it from the 8x, plus negative if you want. So line up your symbol, and we have 6. 8 minus 5 is 3x, plus negative 18. Okay, wall, dot circle. Now is that multiplying number? The number that's multiplied by x is a positive 3, so the symbol won't change. Okay, but you have the negative 18 with it on that side of the wall, so you got to go 18. You would plus 18. Line up your symbol. 6 plus 18 is 24, and then you got 3 dot x. And now we can divide by 3. Okay, so x comes after the symbol, and then on the before the symbol we have 24 divided by 3. That's 8. So 8 is the critical number. Now the sign opens up or eats the x, so it's going to go this way. Okay, number 6. Negative 1 less than or equal to 2x minus 5 less than or equal, minus 3, my bad, minus 3, 11. Now we have two symbols right there and right there. So we need a graph with the 0, but we need to make a table now. And when we have two symbols together like this, we make our overlapping circles. So on one side I put negative 1 less than or equal to 2x minus 3. The other side I put my 2x minus 3, and then that symbol, and then 11. So you're solving two inequalities this time as opposed to one. So the wall goes up, dot circle. Now that 2 is a positive, so the symbol is going to stay the same. And then we got that negative 3 there, so we plus 3. Plus 3. So negative 1 plus 3 is 2, and then 2 dot x. Now I divide. And now I can come down here after I divide. The x is by itself. It's after the symbol. 2 divided by 2 is 1. Now don't graph that till you get the other side done. Wall goes up, dot circle, again it's positive, so the symbols will not change. We have this negative 3, we have to add 3 before we divide by 2. And now I can divide by my 2, and then I can come down here. So x now is before the symbol, and then on the other side we have 14 divided by 2, which is 7. So my critical numbers are both positive, 1 and 7. So let's talk about the 1. It eats the x. Okay, when it eats the x, it's going this way. The 7, fill it in when the line's there. It eats the number, so it's going this way. Okay, that's what we have. Any number between 1 and 7. Okay, number 8. We have an absolute value greater than 1. So again, we need our number line. And absolute values, we always make our table. Now, inside the absolute value, and by the way, this 1, since there's nothing outside our absolute value, we label this 1 from 0. Units from 0. So it's 1 unit from 0. Well, there's two places you can be 1 unit from 0. You can be at 1 and you can be at negative 1. and then you line up your 2x minus 7. With the positive, you use the symbol that's there. But with the negative one, that symbol has to flip, and I put 2x minus 7. Okay, now we can solve it. Wall goes up, dot circle. We got positive 2, so at the end the symbol will be the same. We got a plus 7. So that's 8, 2 dot x, and then divide by 2. And now the x is by itself. So x before the symbol and 4. Okay, same thing here. Symbol's still not going to flip. It's still going to be this way, because that's a positive 2. If that was a negative 2, I'd flip the symbol. That's why the dot circle is so important. Plus 7. So 2 dot x, negative 1 plus 7 is 6, and I can divide by 2. And we got x and 3. Okay, so we have 3 and 4, not a very wide range of numbers. So with the 4, it eats the x, so it goes this way. With the 3, it eats a number, so it goes this way. So x is any number this way or this way. It just can't be in between them. Okay, number 9. Now it says solve the equation. Solve the equation means you don't have to make the number line. Okay, we have the absolute value of x plus 2, and then outside there we have plus 4 equals 7. So we know we need that table, but I don't have the units from 0 because we have something outside of the absolute value. We have an operation outside the absolute value. You have plus 4. So to find the units you are from 0 to put down here, you have to do the opposite of plus 4, which is minus 4. So that's 3, and we have the absolute value x plus 2. So now that you don't have any numbers outside the brackets, now you know your 3 units from 0. Okay? So I could be at 3 or negative 3, and the symbol's just an equals. Okay? I don't have to worry about flipping it. Then I go x plus 2. Okay, wall, 1 dot circle. And it's just an equal, so I don't have to worry about the sign switching. So minus 2, 1 dot x equals 1, divide by 1, x equals 1. Minus 2, 1 dot x equals negative 5, and then divide by your 1. Negative 3 minus 2 is negative 5. And those are your answers, and you don't have to do the number line because they're just equals. X has to be exactly 1 or exactly negative 5. It can't go anywhere on a number line. Okay. Number 10. We have 4, absolute value x plus 5 equals 8. Now again, you're going to make your thing, but you don't know your units from 0 because you have this 4 here. Now the 4 being in front of the absolute value means it's a times operation. The opposite of times is divide, so we have to divide by the 4 to get rid of it, and then divide by the 4 here. So that's 2, and then absolute value x plus 5. Now the only thing outside the bracket is a 2, so that's how many units you are from 0. Units from 0. Remember, to be 2 units from 0, you could be at 2 or you could be at negative 2. And then you go x plus 5. Okay, wall goes up, 1 dot circle, minus 5. 2 minus 5 is negative 3. Divide by 1. So x is exactly negative 3, or x could be exactly negative 7 divided by 1, negative 7. So those are your 2 possible answers for x. Okay, then we get into the story problems. Okay. We have, and I gave you the symbol to use when you have something. It's less than or equal to, you can't go over it. You have 240 feet of fence to put around a rectangular garden. The width of the garden has to be 50 feet. Write and solve an inequality that represents the possible lengths of the garden. So draw your garden, put length, length, width, width, and you're putting a fence around all sides. Now you only have 240 feet. Now what are you going to write over here? Well, how many lengths do you have? You have 2. So I have to go 2 times the length and then 2 times the width. And I know that the width has to be 50, so get that W out of there and put 50. So 2 times L is 2L, and 2 times 50 is 100. So over here I write 2L plus 100. Wall goes up, dot, circle. Do my number line there. Okay. Now we don't flip the sign because it's a positive 2, so we have to minus 100. And that side's now 140, 2 times L. And then when we divide by 2, we go down to where the final sign's at. So L, 70. Okay. So 70, circle, fill it, and it eats a number, so it's going this way. Okay, number 12. My goal, now goal means greater than or equal to, is to average 90 on my tests in geography class. So far I've scored 87, 97, 89 on my first 3 tests. Write and solve an inequality that represents the possible scores I can get on my 4th test to reach my goal. Okay? So write your goal. Your goal now is 90. And you need to do an average ratio right there. So when you took your first test, you ended up with an 87. Plus your next test was 97 plus 89. And you're about to take a 4th test, but you don't know what you're going to get on it. So X. So that is 4 tests. Okay. So you have 4. Now put your X first and then add the other 3 tests that you know. So 87 plus 97 plus 89, 273. Now I'm going to make my wall, but I'm not going to use a dot because I have X's underlined. I got to get rid of this 4. So I would times 4 to get rid of it, and times 4 with the 90. You just take 90 times 4, and then that 4 is gone. The X is no longer underlined. So X plus 273, and 90 times 4 is 360. So now I can make my wall again. Now I can do the dot circle because that fraction's the X is no longer underlined. So sign's going to stay the same because it's positive. So I minus 273 and then divide by 1. Okay, 260 minus 273 is 87. And then divide by your 1 and you're still at 87. Okay, so AX 87. So graph that. Okay, eats the X, so it goes this way. Okay, number 13. This is the last problem here. The specified length of a board is 20.5 inches. The specified width is 25 inches. Each dimension has an allowable variation of at most 0.15 inch. Write inequalities that represent the possible range of each dimension. Okay, so we have to find our length range and our width range. Now when you're finding ranges, you want to make your number line. And you don't want to put 0 in the middle. It says the length is supposed to be 20.5, and that goes in the middle. And then the width is 25, that goes in the middle. Now to find what the range is, you got to take your 20.5, and you need to first plus the variation, which it can go up by 0.5. Or it can go down by 0.15. Okay, so 20.5 plus 0.15 is 20.65. Then I can go back the other way and minus 20.5 minus 0.15 is 20.35. Okay. Now circle, fill them both in, and you just connect them. Now I would like this labeled. I'd like you to put L for length, and I want you to put the 20.35 here and the 20.65 here. Now 20.65 is the very highest number you can have, so we have to always eat the very highest number. This is the lowest number. We never eat the lower number, okay? Here we have to eat the L. The symbols look exactly the same as they should. On a range problem, that's how that works. That's how that's set up. Okay, then the width is done just like the length. We're supposed to be at 25, but we can add 0.15, or we can be 0.15 less. So if I add, that's 25.15. And if I subtract, that's 24.85. So again, put the letter, the W and then put your minimum and put your maximum. You always eat the maximum, but you never eat the minimum. You got to eat the letter. Between the letter and the minimum, you got to eat the letter, because the letter's got to be higher than the minimum. Could be equals too. Okay, and that's how those answers look.